Well, we're sticking with two themes now. First of all, the technological theme, and also the German theme, because we started with Keller Goodman, and then we heard that PCL is part of the Born Group, and now we're moving on to Schaeffler. And I, like many of you, probably here at Auto Mechanic in Birmingham, took time to go to the Schaeffler stand and actually had the opportunity to have the whole tour of the stand. And the technology on there absolutely blew my mind, and it sort of brought home how much is changing and what our technicians are going to need to know in the future. So without further delay, please welcome to the stage Mark Dolloway, the Sales Director, Automotive Aftermarket for Schaeffler UK. Mark.
Good afternoon everyone. As Stefan said, I'm the Sales Director for Schaeffler Automotive Aftermarket in the UK. I'm joined today by my colleague Tim Adams. Tim will be working on the booth that we've got in the atrium area outside to take you through any demonstrations of anything you find of interest today in the presentation. So as Stefan said, I'm going to primarily talk about Schaeffler's view of mobility for tomorrow, so where are we going to go in the future in terms of transitional technology like hybrid and then fully electric vehicles in the future. We'll also touch on some other innovations from the Schaeffler Group, one of which is IARC, our anti-roll stabilisation system, which I think is quite poignant given the audience today. And then also the potential for wheel bearings in the UK aftermarket and how perhaps some of you guys could maximise that with the correct investment in tooling and training. So first I'd like to say thank you to the NTDA for inviting us along today to present at your conference. I hope you'll find some of the information in here useful and good. As you can imagine, as a large company, we're quite often asked to go along to industry events and talk, present, and I just wanted to share with you a couple of photographs of various events that we've been to recently. I hope we get a better response today. Okay, so who are Schaeffler, for those of you that don't know us? We're a 13.3 billion euro turnover family-owned business, a German company. We have about 88,000 employees globally, in 50 different countries across 170 locations within those countries. We split into two divisions, industrial and automotive, but really we're an automotive specialist company where pretty much 75% of our turnover is working with the OE vehicle manufacturers, and we're part of that division in the aftermarket. Wherever you look, you'll see our products. So be it a little 0.08mm bearing in a dentist drill, to a 3-metre bearing in a wind turbine, the central bearing that's found on the London Eye, and even in space, you find our products. So we're a very innovative company and present in lots of different industries. But in the aftermarket, we're better known for our brands. Our brands in the Schaeffler Group within the automotive aftermarket are Luke, ENA and FAG. So LUK is our transmission and clutch brand, ENA engine components, and FAG is our wheel bearing brand. So, in terms of mega trends, this is all what we hear about in the news. There really are four major ones affecting what we do in society and certainly within our industry. Climate change is a pretty obvious one. We're all talking about CO2, our reduction of greenhouse gases, and also limiting our impact on precious resources that we have on our planet. Urbanization. By 2025, we're told that 60% of the population will live in what's termed as a mega city. So with that, we'll bring our own challenges in terms of mobility and being able to navigate around these big cities. Globalisation, we touched on Brexit earlier, so who knows whether this will change, but trade, there are no boundaries to trade nowadays. Free products and free trade move all over the world, and again, mobility is a big part of moving those products around the world to different customers. And digitalisation, Neil covered that earlier, but obviously we can talk about the connected car, which we'll touch on a little bit later, but digitalisation and the Internet of Things is something that's really affecting our lives as a whole. I'm sure some of us here have got refrigerators that like to order our milk from our preferred supermarket already in our households. So from a Schaeffler perspective, what is mobility for tomorrow? We broke that down into four specific areas. So we talk about urban mobility, which comes back to the mega cities. How are we going to get around these highly congested cities in the future? Energy chain, so talking about really smart and efficient fuel solutions for the future. Into urban mobility, aircraft, making them more fuel efficient, and rail to reduce congestion. And then the one which we'll focus on more today, which is eco-friendly drives. So how can we optimise the internal combustion engine as it stands today, and then to also look forward into the future into hybrid and electric vehicle technology. So, we all read the newspapers and the news apps, and we can see that Volvo have stated that by 2019 all of their vehicles will only be electric or hybrid technology, so some of them will still have an engine. Jaguar Land Rover also released the same from 2020, so ending the production of only vehicles containing internal combustion engines. And then we have the British and French government saying that by 2040 they're going to ban the sale of all diesel and petrol vehicles, and China also saying the same, but without a date. So from this, we can see there are certain growth drivers from which vehicle manufacturers will look to produce vehicles in the future. Electrification. With the stricter CO2 reduction targets that have been given to vehicle manufacturers, there is only one real way they can go, which is to go with some form of electric vehicle to reduce those CO2 figures. There will be transitional technologies, so hybrids, as I said before, but also battery electric vehicles. Autonomous driving, which Neil covered beautifully, I don't need to cover that any further. Connectivity. Again, we talk about the connected car. One scary prospect, certainly for the aftermarket, is that the connected vehicle can diagnose itself and decide that it needs a repair or a service or a part replacing, and then fire that off to the dealership and make an appointment on your behalf for you to take the vehicle there. Of course, in the aftermarket, we would like to intercept that to be able to work on those vehicles in the future. So, very much a two-pronged attack there. And the added value of automotive suppliers such as ourselves. So, the automotive vehicle manufacturers really want modular solutions, and something even as simple as the humble wheel bearing has gone through many transitional changes to a very nice, easy mountable modular solution today. This is very much a Schaeffler view, and you may or may not agree with the way in which technology will move forward, but you can see here 2015, the closest date. As we know, most of the vehicles on the road contain an internal combustion engine. In a very short space of time, we see that probably by 2030-ish, that split will roughly be 50-50. So 50% of the vehicles will still be produced with internal combustion engines, and that will be, I guess, more in Africa or areas that are not really set up in terms of infrastructure to be able to take on electric vehicles in the future. But you can see here that 50% will either be transitional technology or with battery electronic vehicle technology. So, e-mobility. If you talk about Euro 6, which was just touched on itself, it had some really stringent rules in place to be able to reduce the emissions of vehicles. So 50% of reduction on NOx emissions, AdBlue, being a good example of ways in which they're controlling that. And also the reduction in CO2 emissions by 2020, 180 grams per kilometre to 95 kilometres. That's just simply not achievable without some sort of electric vehicle technology being introduced into their ranges. And just by comparison, the difference between Euro 4 to 5, that reduction was only 20%. So you can see they're going to continually ramp this up and make it more stringent. And of course the reason for that is that we have no planet B. So we need to look after the one we're on. Just cutting through the jargon a little bit, obviously I think we've all heard of a hybrid, and we've all heard of a FEV. They're fairly common phrases used in hybrid technology, but within those there are some other categories. And then, of course, there's the fully electric vehicles, such as the Teslas and the Nissan Leaf that are available in the market today. We could almost liken this a bit as complicated as ordering a coffee nowadays, with all the different selections that we have to make when we go into a coffee shop. And of course, this is what we all remember an electric vehicle looking like, something very different to what we have today. So, what are the car manufacturers saying? Well, most car manufacturers are saying that we'll have at least one electric vehicle in their range by 2020. Volvo, as we've already heard, they're planning on having a range of electric and hybrid vehicles by 2019. Ford are planning 13 hybrid, plug-in hybrid and electric vehicles by 2020. BMW, they want to go fully electric by 2025, which is very ambitious. And GM plan to also release around 20 new electric and also hydrogen fuel cell technology vehicles by 2023. And the German authority on vehicles, whose name now escapes me, but the German car manufacturers will start making the internal combustion engine in around 6 years' time. So again, a very ambitious target. And of course, what's the truth? Well, I don't think anybody really knows, and the crystal ball is very cloudy. One of the big issues, if you look at this from a UK perspective, probably replicated in most other European cities, is motorway services, for instance. If you look at that, how many charging points are available? Most have 2, I've seen 6 maximum at the service stations I've certainly stopped at travelling up and down the country. Here today, I think we have 4 outside the building, and also the shopping centre we went to last night had 2. How many cars are in a car park at a service station? Yeah, where's the infrastructure going to come from to be able to charge these vehicles? And we've already warned from this. Various bodies and think tanks have highlighted this already to the government and said, how are we going to grow the infrastructure to be able to manage with this surge that will be predicted? And certainly the government are really pushing to increase this surge in investment in electronic vehicles with the vehicle manufacturers. And then we look at something like Hinkley Point C. I think we're all fully aware of Hinkley Point and how long this has taken, but again, 1.5 billion over budget and another year behind schedule to provide the power that we need today. How many Hinkley Points will we need if every single vehicle we're driving is electric in the future? I think it's pretty safe to say that the government really accelerated the death of the diesel a few months ago. They really have stuck the nail in the coffin, I would say. That led a lot of the vehicle manufacturers to come up with scrappage schemes, as they did before, during the recessions in 2008 and 2009. So who's offering them? Well, I'll tell you, everyone is offering them. So again, they're really trying to push diesel out of the market, and the only offer that they're making on these vehicles is on electric vehicles. So some pretty impressive numbers there. 10 grand off a VW Golf GTE, which is the number 4 selling car in the country. I think that's a pretty impressive offer and will make people think about this technology going forward. And the Office for Low Emission Vehicles will also pay a grant of up to £4,500 if that vehicle's listed on their particular scheme. So we shouldn't forget about the humble internal combustion engine as well. Most hybrids will also have some form of internal combustion engine attached to it to take over when the battery isn't running. But with that, we also have to meet those CO2 challenges as well. So engine downsizing is something that's very prevalent within Schaeffler in terms of the technology that we're moving forward on internal combustion engines. So downsizing of cylinders, 6 and 4 cylinders down to 3 cylinders. Turbocharging to keep the power up of the vehicle so you still get the comfort of the vehicle you would have had today. Idle down speeding are all things that are really hot topics for us in terms of creating that technology and taking that technology another stage forward. And then 48 volt systems. 12 volt really is at the limit of its capacity and has been for some time now. But 48 volt systems are definitely more prevalent. If you do the maths, it's a 4-fold increase in power, so you can take the power that's available to the vehicle from 3 kilowatts up to 12 kilowatts. And because of its lower ampage, you can also run much thinner cables, which of course offers weight saving within a vehicle. A friend of mine owns a garage and he had to do a complete wiring loom change on a BMW M3 recently, and I've never seen so much wiring in my life. It was quite scary. So there's a lot of weight in cabling in a vehicle. And of course, the challenges for the independent aftermarket, just as been described many times today, are quite prevalent too. Orange means danger. You know, these cables are running various voltages, up to 1,000 if it's a high voltage system on a vehicle. And to be quite frank, if you come into contact with those sorts of voltages, there is only one outcome for the installer that's working on that vehicle. So training is key, and so is the tooling for discharging the systems, particularly if it's a crash-damaged vehicle. And of course, if you touch it, the outcome might not be too good. So the history of hybrids goes back further than you'd think. The Armstrong Phaeton was a dynamo electric system running a battery and an engine, a small engine. The Lola Porsche was probably something akin to what Tim is demonstrating out in the atrium today. This had 2 electric motors fitted to the 2 front wheels there on the front, again powered by a battery and an engine. And of course, if we head and zoom forward to the late 90s, I think we all pretty much have heard of the Tyre to Prius, which really did bring that hybrid technology to the masses. But up until April 2016, there were 11 million vehicles sold worldwide that had some sort of hybrid or electric technology contained within them. So, what's on offer? For the vehicle manufacturers, from our perspective, there are a number of different products that we talk to them about. There's keeping the traditional internal combustion engine and adding a micro-hybrid system to the front of that engine to enable it to have some form of hybridisation, so a very cost-effective solution. There's a 48-volt mild hybrid, which again takes a standard high production vehicle and adds a hybrid technology to that. There's a hybrid vehicle, which we're all aware of, Tyre, Prius, Lexus, plug-in hybrid systems and full electric. So, micro-hybrids. Micro-hybrid can be summed up by a vehicle that can't propel itself on electric alone. but has systems that are electronic and hybrid to be able to reduce the CO2 emissions of that vehicle. Most of us will be aware of start-stop. I think it's been a pretty standard option on most cars for a number of years now, but they've added a coasting function to that, which I'll touch on shortly. Belt starter generator system, electronic clutch, and some sort of shift detection system or mechatronic system in case of an automatic or a semi-automatic vehicle. So, very compact modular system, going back to this modular solution for the OE manufacturers to bolt on the front of an engine. This is an example of a small unit containing a generator system and also a coasting function. If we turn that around and look at the back, you'll see that the flywheel is also present on this system because you were able to decouple the clutch and coast the vehicle, which of course means the engine or electronic system removed goes back to idle, therefore reducing the CO2 emissions of that vehicle. And then the Omega tensioner. These systems tend to be belt driven, so again it's a serviceable item that needs checking regularly because the tension that these are under is probably 20 times that of a timing belt. So they're under a lot of pressure, hence the big spring within that system. Most of these systems will also have some sort of regenerative braking system. So under braking, the electric motor that's mounted to the front of the engine switches to generator mode. The wheels then by the drivetrain drive that generator, creating electricity which gets stored in the high voltage battery within the vehicle itself. And then when it's braking from speed, the vehicle doesn't need to use the friction material to slow down because it's using the generator itself to slow down the vehicle. So again, a reduction in the service items of discs and brake pads in the future. And then when the vehicle comes nearly to a stop, there's not enough power in that generator to slow down the vehicle anymore, and your traditional brake pads and discs will take over to bring it to a stop. And we move on to the mild hybrid systems. So who's looking at mild hybrid and 48 volt? Everyone, to be honest. It offers a really good cost-effective solution to be able to take cars that we currently drive today, such as Golf or the Audi TT as we showed there, and turning that redundant rear axle into some sort of hybrid or electric system. Again, offers a very low-cost solution for the vehicle manufacturers to hybridise their vehicles. This is an example of a rear axle system, one that's actually fitted to that TT and Golf platform, very, very popular platform. And it basically turns the rear axle into an electric vehicle, and the front end still has the internal combustion engine doing what it was doing before. They can be also coupled up with the previous technology I showed, so what's available on those micro hybrids, coasting functions, e-clutch, electronic, mechatronics, changing systems to maintain efficiencies, and also generator systems for regenerative braking. So, this has already moved on another stage. That was very much a stage 1 system, quite a big system. As with everything, it gets smaller. This is the phase 2 electric motor that we're currently working on for hybrid vehicles. See, it's a very compact unit. It's designed to fit between engines and transmission systems, both on automatic, semi-automatic vehicles, whether the engine's longitudinal mounted or transverse. It's a very, very easy, cost-effective solution to put in. And you'll see there, 800 Newton meters of efficient torque being added to that vehicle. And I think if anybody's driven one of the most recent FEVs, the initial take-up of power you get from those vehicles is quite amazing. And then the ultimate hybrid. We also work with Porsche on the 919 LMP. Right, onto full electric vehicles. The demonstration kit we've got out here today is the e-wheel. The one we've actually got on show here is generation 1. I'll show you the other generations shortly, but that was the one actually featured on this Fiesta. E-wheel drive system is something that we've been developing a long, long time. Now it's been through all the standard durability tests that we would offer on a wheel bearing or a clutch to our OE vehicle manufacturer customers. So it's been on test for 4 to 7 years to make sure it's a durable system to be able to put into production. And that's been from -40 to +50 degrees, again, just as we would do with any other product release. Basically, it's an electric motor in each wheel of the vehicle. And a vehicle manufacturer can choose to take 2 of those, have a 2-wheel drive car, or turn that into a 4-wheel drive vehicle. I won't go into too much detail inside, but it has got a wheel bearing in the centre because it needs to turn. And the braking system you'll see is done by a friction brake system, which is kind of like a maglev system, I guess, to make it easier to translate. But you'll see again, the power output of these is quite incredible. 350 Newton meters constant output from one of these. If you have 4 of those on a Fiesta, that will make a really quick Fiesta. The big don't touch cables again, coming to the back, it's high voltage, so it needs a a high power output to keep those motors turning on the vehicle. And this particular system also needs cooling. You can imagine the temperature, and you all know the temperature of a tyre when that comes off the road. We imagine all of that electronics also in the centre of the wheel too, so it needs an integrated cooling system, but all of the other systems behind it are as a normal car today, so shock absorbers, springs, etc. In summary, integrated system that allows a lot of new vehicle concepts. You can imagine with the technology of batteries shrinking as they are today, it's possible now to get batteries in the chassis of the vehicle, so you don't need an engine. So what traditionally would have been the bonnet of a car housing an engine, that can actually be taken away now. You can literally have a car with four wheels in the corner and create lots of space inside in a fairly compact design for you to have as a family vehicle. So as I said, 3 generations, we're up to a full production version now. Step 3, the gamma system that we call it, is able to mount into an 18-inch wheel, so we're not confined to having a wheel system that's fully integrated. It can go into any 18-inch wheel offered by a vehicle manufacturer. And again, that's up to about 500 newton meters of torque now, so we also increase the power output of that system. You'll see it's quite compact, fits inside the inside of the rim very, very easily, so not much more than you would see from the rear of a brake disc system that's currently fitted to a vehicle today. And then also, the battery unit on this Fiesta is quite large, battery and cooling unit, but again, as that technology moves forward, it will shrink considerably with lithium-ion technology. And it also has the benefit of being able to turn the wheels 90 degrees. So again, if we talk about really congested cities and parking, you can literally turn all 4 wheels 90 degrees and drive the vehicle into its space, no more parallel parking. This is our latest electric motor system, the e-drive, again an axle mounted system, but much more compact than the ones that I showed you on the mild hybrid. And again, power output is phenomenal, 280 brake horsepower, 100 kilometres of range at full power. So we really see the momentum building on these hybrid technologies. So in summary, we've got the micro hybrids, which is a bolt-on system on the front. A vehicle that's not able just to go under electric power itself, but offers some benefits in CO2 reduction, which would be in the region of about 10%. So again, quite significant for a vehicle manufacturer. Mild hybrid systems, which sit in the middle, and then the full electric battery systems, which tend to be on rear axle applications in our design. And of course, as the grade of electrification grows, then so does the CO2 reduction targets that the governments are putting in place reduce. And again, for those of you that watch Formula E, it's a very strange one to watch with no noise if you're a Formula 1 fan. But we are Formula E, and a lot of our technology is present on the Team Audi ABT Schaeffler car that's doing very, very well and has done for a number of years in Formula E. As I said earlier, I just want to touch briefly on the IARC stabilisation. Again, we've got an example of this, a cut section of the IARC system available in the booth for you to take a closer look at. Why does it exist? Well, the system itself is designed to take what was the humble anti-roll bar, very, very standard fitment, I would say, to most vehicles for many, many years now, and adds the addition of a couple of motors, and those motors are designed to counteract the forces that the vehicle is under during steering, braking and turning. I've got a short video just to show you this and highlight this. It's quite amazing to watch. So the result is that you don't get any tilting of the vehicle when it's cornering or under heavy loaded braking, a reduction in fuel consumption because it's not trying to drive those tyres out of the bends as you're trying to accelerate out of a bend, and more precise steering. And the solution, of course, can be fitted to all the types of vehicles that the vehicle manufacturers are talking about today. So this is just a very short video of the Bentley Continental GT going around the Nürburgring. It's a test vehicle, so it's taken by a spy camera. But you'll see from the video the lack of tilt as it goes around the at that point for any people that have been over to the Nürburgring. So quite an amazing bit of technology. And then just want to touch briefly then on the wheel bearing market and where that is today, given that we're talking to the tyre industry today and you're very much involved in that area of the vehicle. Wheel bearings are often seen as a commodity. I think that's very safe to say, but they are safety critical, extremely safety critical. You wouldn't want a wheel coming off on a motorway due to that bearing being fitted incorrectly. And then of course you wouldn't expect it on a plane either, but that was my flight here this morning, not really. Yeah, even more prevalent in the airspace industry to make sure that wheel bearings are installed correctly on the vehicle. That was a wheel bearing failure on a Bombardier Dash 8. So, in 2016, there were 32 million vehicles on the road and 3.7 million LCVs, all with roughly an age of 8 years. So that's, as a summary, they all need wheel bearings. And even with the future of engine technologies a bit in the air, I think one thing is a constant: they all have a chassis, and they all need to roll and move. So I think wheel bearings is a good area for the aftermarket still to focus. And it's good business. If we look at the OE production of a vehicle, it tends to be in the region of 9 or 10 years, but then that vehicle stays in the market for 20 years from its inception, generally. So you can get good longevity out of a wheel bearing product. From an FAG perspective, a little bit of sales pitch now, but you get the OE kit. So if we're the OE manufacturer of that bearing, you'll find the OE FAG bearing in the box, but whoever is the OE bearing manufacturer, you'll find that in our kit. And more importantly for us, all of the components are also the OE components. So you really are offering the highest quality components to your customers. In terms of generations of bearings, for those that are not so aware, taper bearings, younger people probably remember these so much, but it was prevalent and every single vehicle was running on a taper bearing many, many years ago. Had a range of about 18 to 25,000 miles, depending on how well it was maintained. We then moved on to the Generation 1 bearings, so the first of the hub bearings, if you like. Again, 30, 40, 50,000 miles, depending on the road conditions and how the vehicle was driven. Generation 2, which is probably the most popular bearing nowadays, again lasts in the region of 70, 80,000 miles. And the Generation 3 completely modular hub units, you're looking at 100, 120,000 mile plus longevity. So you can see why that technology has moved on from a vehicle manufacturer perspective. A taper is now not fitted at OE, it's pretty dead technology to be honest. Mercedes-Benz were the last people to use that on things like the Sprinter. They moved to Generation 2 bearing. But you'll see the other three are prevalent still at OE. All three of those bearings are being fitted by the OE vehicle manufacturers. We took some visits to a national auto repair group just to talk about wheel bearings. We asked the question, are you doing wheel bearing work? They said yes, of course, we do some wheel bearings. Very low volume though was the comment. They did use OE bearings, which is great, of course, to hear. That's the right thing to offer to the customers. One of the more scary thoughts, though, was that they didn't know that there was a special tool required for Gen 2 on install. You can't fit one of those bearings without the correct tooling. Hammering it will not work. And the message here, of course, is potential. So, the bearing is not just a bearing. It's responsible for a lot of systems on a vehicle, be it ABS, ESP, hill start, hill hold, tyre pressure monitoring, which we've already touched on today, so non-active tyre pressure monitoring systems, and things like speed sensing. Again, it has to be installed the right way, it has to be checked. It's quite scary to walk into most independent garages and ask them how they test and encode it. They often say, I use a screwdriver. Well, magnet is only one outcome. One of them is going to die, and that little tiny magnet in the bearing is probably the one that's going to suffer. So you fit it to the vehicle after you've tested which way to put it around, and you have an ABS form. We do a very simple tool for that that's free, so you can check either which side the bearing should go, but more importantly as to whether it's got any dead spots on the bearing before you install it on the vehicle, because you don't know whether the delivery driver maybe dropped it on the way into that product coming to you. But as a bare minimum, a little piece of metal will also tell you the right way to install it, but of course won't be able to diagnose whether the bearing's got a fault for you. As time has moved on, as I said earlier, the bearings have become more modular, but a lot of patents have been put to that. It's now very expensive to tool up to be able to produce a wheel bearing for an OE manufacturer. When we're talking about modular units, you're probably looking at 40 to 50 manufacturing processes in that alone. We're a very patent-orientated company. We're the second most innovative in Germany behind Bosch. And in 2015, as you see there, we registered over 2,300 patents for automotive vehicle technology products, including wheel bearings. So going on to the tooling, Generation 2.1 bearing is probably the most popular. You'll see in 50% of cases now, this is the bearing that's going to come into your workshop for replacement. In terms of tooling, there are 8 different sizes of flange, outer flange on the bearing itself. I would say out of that though, 4 are probably the most popular, the others less popular. And if they're not fitted correctly, this is what happens. This is a warranty that we did go out to and look at on the vehicle, so the wheel had come out on the vehicle, and upon closer investigation we could see that the bearing had become adrift because it wasn't pressed into the hub correctly and the snap ring had not located correctly on the vehicle. You imagine 70, 80 mile an hour on a motorway again, and that wheel coming off, profits. It's a way of thinking about it, really. And then you've also got the added problems of also dragging the CV joint through the hub. So it's not just a wheel bearing replacement anymore, it's a CV joint and full hub replacement on the vehicle, which can be very, very expensive on some vehicles, particularly if the front end is aluminium, for instance. The tooling, we don't do tooling, Schaeffler don't sell tools, but it's available from many, many different tool manufacturers. It's a very, very simple tool to use. It's available to be used on vehicle or off vehicle if you do have to remove the hub for whatever reason. Tim has also got this demonstrated outside for any of you guys that want to take a closer look at that as well. And the idea is that of the tool is that it fits and applies the force in the correct place of the bearing when it's pulling the bearing into the hub to allow the snap ring to locate properly in the hub itself of the vehicle. And the final innovation, which is tooling terms you guys have all got in the workshop anyway, just requires a tool wrench. Generation 3 bearings tend to be held on with 3, 4, 5 bolts, depending on the application, and then the main stud going through the centre of the bearing. The face spline is a new innovation from Schaeffler that you'll see on pretty much all BMW models, also on some up-and-coming Ford, Porsche and VW models. It removes the CV joint. Again, if we talk about weight reduction, there's a kilo runs from mass at the front of the vehicle there. If you can get rid of that, you can also reduce CO2. So another innovation of Schaeffler's there. And Tim's got the BMW i3 or i8 regulator bearing on show just outside in the entry there. So in terms of tooling, what you need? Well, in terms of generation 1, number 1 and 2 there is what you need to repair generation 1 and 2, generation 1 bearings. In the various visits we've made, some national auto repair centres do have presses. Not often did they have the sleeves to actually press the bearing into the hub though, but they're fairly inexpensive investments. Generation 2, depending on the amount of sleeves that you have in the kit itself, you can be looking at anything from 150 to 650 pounds, again depending on where you buy your tools. Number 4 there is a specialist one for Audis, torque wrench, which I'm sure you guys have all got, and a slide hammer, which I imagine most people will have in their workshop as well. So in that there you've got the coverance of all of those wheel bearings. So you're able to take on those repairs. Now what does that mean in terms of numbers? I would say that given the change rates, the number of vehicles on the road, the UK vehicle car park, which you said earlier was 32 million. On average, each workshop in the country should be doing around 3 to 4 wheel bearings a week. If we take that as a labour of 1.5 hours to 2 hours on each wheel bearing, it's good business. It's good business. It's not tied up your ramps for hours like a clutch would. We've been asked on a number of visits, could we get into clutch? Well, if you can bear to have your ramps locked up for 6 to 8 hours, maybe it is an option for you, but wheel bearings is good business for you. And in terms of support from Schaeffler, we have another brand, which is Rep Expert, which is our training brand. It's available as an online system to download all of the technical information that's available on the Tech RMI, so that relates to our products, but also anything else you're doing on the vehicle, anything that's in the database. So think of it as a free auto data when you buy our products. In each of our boxes are the points which you redeem, and then you spend on that technical information and then accessing it online. We have a technical hotline manned in our head office in Hereford. 4 technical hotline staff. We take a lot of calls, 14,000 per month, so it's a well-used line and offers good service, and anybody that's used that before has always come back with very positive support on the help we've been able to give them on that vehicle problem they were having. And you'll see us at every show. Any of you guys that visit the mechanic, as Stefan said, and the other shows that we do throughout the country, all of our guys are trained, the technical sales team, and not just a sales team. And we'll come and do bespoke training at head offices, or head office training facilities for anybody that needs us to come along and help. We also have some vans. Tim calls them Thunderbirds 1, 2 and 3. We have 3 vans, one in the south, one in Midlands and one upon the border of Scotland, also to be able to carry out training. They're fully equipped with all of our training racks. We can do it in all weathers if we can bring out the gazebo at the side of the van as well. And the team that's available up and down the country is always available to help you guys out with any issues that you might have. And that's it. So thank you very much for your attention.